Welcome to Unit 1.5, Operations with Radicals. Last lesson we talked about simplifying radicals. Now we're going to work with the operations, starting with example 1, adding and subtracting. If the roots is the same in the two different terms, we can add or subtract the like terms. Add or subtract. So when you look at the example A, if you see the radical term is the same, which in this case we have the 5 root 5, we can just look at those just like adding like terms. So we can use these coefficient terms, the 2 and the 7, add them together, and we know we have 9 root 5. So the same thing works through subtraction and adding. If we look at example B, we're looking for like radicals. So we have a 3 and a negative 8, or 3 minus 8. So we need to subtract, and we have negative 5 root 6, and then we have the plus 4 root 3 plus 2 root 3 that have the same radical terms. So we can write that as 6 root 3. Now when we look at example C, these do not have the same radical, so we do want to look to see if any of these might be able to simplify before we move on. And in this case, we're looking at this 18 breaking to 9 and 2, and you should recognize that 9 is a perfect square, so we could rewrite that, bringing out the 3 as a 6 root 2. Well, look at that. 4 root 2 plus 6 root 2. This allows us to rewrite this and combine like terms to be 10 root 2. Again, with example D, we're looking at different radicals, but if we want to combine them, we need to see if they will reduce. This term will reduce. So again, with the 9, we know that can be rewritten as 3 root 5. So now we have a 10 root 5 minus 3 root 5, and that will equal 7 root 5. And that's it. Looking at example 2, as long as we are multiplying radicals, and as long as they are the same, square roots, both square roots, we don't have cube roots or any other thing, we can just look at this a times b and basically bring them under the same radical term. So if we look at this and say, all right, there's a square root of 3 times square root of 12, this allows us to rewrite this, multiplying the 3 times 12, and then, of course, we always want to look to simplify. So square root of 36, that should stand out as a perfect square, equaling 6. If we look at our next one, same thing's going to apply if we're multiplying. Now we do want to multiply any of our coefficient terms separately. So if we look at 3 times 4, that is 12. And then if we look at our stuff underneath the radicals, 2 times 3, root 6. Now if we break up root 6, the only thing we could do there is 2 and 3. So that radical is already as simplified as it can be, leaving us with our answer of 12 root 6. And looking at our last example 3, dividing radicals. This right here is going to state that if we have a square root over a square root, we could combine them into 1, and vice versa. So this this whole statement goes both ways. So we'll take a look at each of them. First thing we're looking at is the square root of 15 over square root of 3. Looking at that, nothing can simplify under the radicals, but if we use that property to bring them under the same one, well, now what is 15 divided by 3? Well, that's the square root of 5, and in this situation doesn't allow us to simplify anything. So our answer is square root of 5. If you look at this second example, the square root of 49 divided by 4. Well, fraction in itself does not simply is not very simple to simplify. But if we break this up to say the square root of 49 over square root of 4, this should stand out to us that, oh, the square root of 49, that is a perfect square of 7. And the square root of 4 is also a perfect square, which would be 2, leaving us with the answer 7/2. Okay, that was a look at all of our operations with radicals. So now take a few minutes to practice 1.5a and answer these 8 questions before moving on and checking your work. All right, good luck.